This is our review 3.4 for our first unit on trig, right triangle trigonometry. In a right triangle, the acute angle theta has a cosecant of 7/4. So I want to draw a right triangle, which is a theme for almost every problem here. You want to draw a triangle and then figure out what you know. So the right angle, here's my right angle. I draw that. And it says the angle theta. It can be either of the acute angles that are remaining. So I'm choosing the one on the left. You could choose the one on the top. Does not matter. It has a cosecant of 7/4. Okay, so if I think about it, you need to know all of your trig functions. So SOHCAHTOA. And I know that the sine is the opposite over the hypotenuse. I know that the cosecant is the hypotenuse over the opposite. So if they tell me the cosecant is 7/4, that means the hypotenuse is 7 and the opposite side is 4. So I just need to figure out what is this side down here that I don't know. And that's where I will use the Pythagorean theorem. So x squared plus 4 squared equals 7 squared. That means that x squared plus 16 equals 49. If I subtract 16 from both sides, I get that x squared is equal to 33, so x is the square root of 33. So I know that that side is the square root of 33. So this side right here is the square root of 33. So now I just need to figure out what is the cotangent. So the cotangent, that is adjacent over hypotenuse. So the cosine, that's what the cosine, figure out the cosine, adjacent, remember that is adjacent over hypotenuse. So that is going to be square root of 33 over 7. That is my exact value for that. The tangent, remember the tangent is the opposite over the adjacent. So the tangent is going to be 4 divided by the square root of 33. No decimals, no approximations. I can do all of this without a calculator. The cotangent, that's the reciprocal of the tangent. So if the tangent's 4 over root 33, the cotangent is root 33 over 4. The sine is going to be 4/7, or that's the reciprocal of the cosecant, which we knew to be 7/4. The secant is the reciprocal of the cosine. So the reciprocal of the cosine is going to be 7 over the square root of 33. So there's not a lot of partial credit on this. You either get this concept and can figure out these ratios, or you're missing that. So it all comes from knowing all the definitions of your trig functions and their reciprocals. Problem number 2, solve for the unknown. And this is where you will be using your calculator. So anytime I'm solving for the angle, I need to use the inverse function. So I've got to use the inverse sign, or the arc sign is another way of saying that. So theta is going to be the inverse sign, or the arc sign of 9/11. So on my calculator, I'm just going to do trig function, the inverse sign, and what was that again? It was 9 over 11. So 9 divided by 11, and I get 54.90. So that tells me my answer is 54.90. I'm solving for an angle. That is degrees, okay? 54.90 degrees. The next one, solving for z. 4 over z is equal to the cosine of 0.4. That means that 4 is equal to z times the cosine of 0.4, or z is equal to 4 divided by the cosine of 0.4. So on my calculator, I will have 4 divided by the cosine of 0.4 and that is 4.0001. So I'm just going to say that this is, so Z is equal to 4.00 or 4. Not a lot of space for this one. X times the tangent of 34 is equal to 12. This means that X is equal to 12 divided by the tangent of 34. Again, straight to my calculator. 12 divided by the tangent of 34, and that is 17.79. So X is 17.79. 12 tan alpha equal 142. Again, solving for the angle. This means that the tangent of alpha is 142. 142 divided by 12. So in order to solve this, alpha, anytime I solve for the angle, that's going to be the inverse tangent of 142 over 12. So again, I'm solving for the angle. I have to use the inverse trig function. This case is the inverse tangent. So the inverse tangent of 142 over 12. So I go to trig function, inverse tangent, 142 divided by 12. That is 85.17. So 85.17, that's an angle. It is measured in degrees. Okay, so fairly straightforward, just using your calculator for some computations. And then we move into the applications or word problems. Each of these is just begging you to draw a right triangle. That's the key to solving this. Tallest television transmitting tower in the world is in North Dakota. It is 2,559 feet. If the tower casts a shadow 5,280 feet, 1 mile long, what is the angle of elevation looking up at the top of the tower? So you've got a television tower. It casts a shadow. That makes your right triangle. So I know that this tower is 2059, that is feet. That's how tall the tower is. Shadows are cast on the ground. So this shadow is 5,280 feet. And I'm being asked, what is the angle of elevation? That means I'm lower than the tower and I'm looking up. So the angle of elevation is this angle right here in blue. So let's just call that angle theta. That is the angle that I'm looking for. So when I look at that angle, what do I know? It's a right triangle. I could figure out the hypotenuse, but if you look at it relative to this angle theta, I know the opposite side and I know the adjacent side. What trig function can quickest get me there? Well, that's the tangent. The tangent of theta is equal to the opposite over the adjacent. In my case, I know that the tangent of theta is equal to the opposite. That's 2059 over the adjacent 5280. Solving for an angle. That is the inverse trig function. So theta is going to be the inverse tangent of 2059 over 5280. So I go to my calculator. I need to find the inverse tangent of 2059 divided by 5280. Let me make sure that I did that correctly. 2059 over 52.80, and I get 21.30. So 21.30, those are degrees. So 21.30 degrees. Problem number 4, okay? An architect wishes to build a house such that the overhang of the eaves shades the entire side of the house during the summer solstice. The angle of elevation of the sun is 80 degrees on the day of the solstice, and the wall of the house is 17 feet tall. How long should the overhang be? So I know that the distance from there to there is 17. That's how tall the house is. And so what I need to solve for is how long that overhang should be. So this is what I'm solving for right here in red, this value of x. So it looks like if I were to draw that triangle up here, so I can see it, I know this, and I don't know how long that eave should be. Now this angle theta, you're given, if you look down here, that this makes a right triangle, so the brick wall with the ground makes a right triangle, and you're given that angle of elevation is 80. So what do I have to add to 80 to get 90? That means this is a 10-degree angle, okay? This was on last year's test. A lot of people messed this up, so I'm not sure if this was too hard for that or not, but you guys can handle it. So it looks like I've got this right triangle. So if you look at that angle 10 degrees, it looks like I know the adjacent side, okay? I know the adjacent side, and I don't know the opposite side, okay? And I know the angle. So the trig function that deals with opposite and adjacent, that's tangent. So the tangent of 10 degrees is going to be x over 17. So that means that if I solve this for x is equal to 17 times the tangent of 10 degrees. I'll go to my calculator. 17 times the tangent of 10, and let me get the approximation of that. That is 2.997. So that's roughly 3.0. So I'm going to just go with 3.0. So it tells me that it should be 3.0, and that's measured in feet. So that overhead should be 3.0 feet in length. Problem number 5. And again, the key is drawing these out, okay? A 16-foot ladder leans against a wall. So you have a wall, you have a ground, and you have a ladder that leans against the wall. If the ladder is 16 feet, that's this side right here, it leans against the wall at an angle of elevation of 63 degrees. How far up the wall does the ladder rest? So I'm being asked to solve for this side. How tall is it where the ladder touches the house? So if I look at this, I know an angle, and relative to this angle, this is opposite, this is hypotenuse. The trig function that deals with that is the sine function. So the sine of 63 degrees sine of 63 is x over 16. So x is equal to 16 sine of 63 degrees. So on my calculator, 16 times the sine of 63, 14.26. So 14.26 feet. That's how far up the wall the ladder rests. How far away from the house is the base of the ladder? Okay, now I'm solving for this distance here. If I look at the angle that I know, 63 degrees, this is the adjacent side. So what deals with adjacent and hypotenuse? That's the cosine. So the cosine of 63 is equal to, instead of x, let me just call this, let me call it z, which is another variable. So the cosine of 63 is z divided by 16. So z is equal to 16 times the cosine of 63. So go to my calculator. So it is, 16. So 16 times the cosine of 63 is 7.26. So that tells me 7.26 feet. That's how far away the ladder is on the ground from the wall. Problem number 6. A wheelchair ramp angle of elevation cannot exceed 4.8 degrees. You plan to build a ramp from your front steps, which are 5 feet high. How long would the ramp need to be to meet your requirements? So you've got a ramp for a wheelchair, and you're told it can only be 4.8 degrees angle of elevation, and it's going up to the top of your steps, which are 5 feet tall, and you need to know how long would the ramp be. So the ramp is, this is your ramp right here, so that's what I'm after. How long will that be? Well, when I look at this 4.8 degrees, it looks like I've got information about the opposite, and I need to know the hypotenuse. That trig function is the sine function. So the sine of 4.8 is equal to 5 over x. That means that x times the sine of 4.8 equal 5, or x is equal to 5 divided by the sine of 4.8 degrees. So in this case, I'll go to my calculator. 5 divided by the sine of 4.8 is 59.75. So that tells me this ramp needs to be 59.75 feet. Okay. Problem number 7. A new 1,000 feet zip line is installed at the tip of the Washington Monument. If the angle of elevation from the ground to the top is 33 degrees, how tall is the monument? So you've got your Washington Monument, and you've installed a zip line that takes you to the ground. Okay. There's your right triangle, and we know that the zip line is 1,000 feet. So this is 1,000, and I know that the angle of elevation is 33 degrees. How tall is the monument? So I'm looking for this variable right here. So I've got an angle, and it looks like this is the opposite side, and this is the hypotenuse. That's telling me to use my sine function. So the sine of 33 degrees is equal to x over 1,000, which means that x is equal to 1,000 times the sine of 33 degrees. So on my calculator, that's 1,000 times the sine of 33, and that is 544.64. So 544.64 feet. That is the estimated height of the Washington Monument. Last problem, number 8. The famous bell tower in Pisa, Italy, was completed in the 14th century. Over the centuries, the tower has continued to lean due to inadequate support in the soil. It's thought that the tower will topple if the tilt angle goes below 83 degrees. Okay, so if the short side of the tower measures 180 feet from the ground to point T, and an object dropped off the short side falls straight to the ground and lands 17 feet from the base, find the angle of tilt. Okay, so they tell me that, what was the distance? 180 feet. 180 feet from the ground to point T. So if I look at it, they're telling me that this right here, that is 180 feet according to this, okay? So that's 180. So that distance is 180. Let me back up so I have enough space to draw that. So I'm just going to draw that is 180 feet. Now the next thing they tell me is that an object dropped off the short side falls straight down and lands 17 feet from the base. So if I drop something and it falls straight down, they tell me that it lands 17 feet away from the base. Okay, here is my right angle. So it'd be a mistake to draw the right angle next to the tower because we know that tower is leaning. Okay, so in this case, if I were to draw this so you can see it a little bit better, if I draw a triangle out here, this is 17 and this is 180. And they've asked me to find what is the angle of which that tower is leaning. Okay, so if I look at this relative to that angle, it looks like I've got an adjacent side and a hypotenuse. That is begging me to use the cosine function. So the cosine of theta is going to be 17 over 180. To solve this, I use my inverse cosine. So I need to figure out the inverse cosine of 17 over 180. So if I go to my calculator, the inverse cosine of 17 divided by 180, that is 84.58. So 84.58 degrees. Now, it didn't ask this, but is the tower in danger of falling immediately? We were told that if the angle goes below 83, they feel like it will fall. So it's slightly above 83 degrees. Okay, wasn't part of the question, but there it is. So anyway, that is the review. Like I said, the biggest key here, knowing your trig functions, when to use which one, and knowing how to diagram and see what you have in the diagram based on the sides and the angles.